Well, I tell you what, let's go ahead and get started. We got quite a few segments to cover this evening. Finishing up the tail end of chapter 4 or module 4, and then the hope is that we'll make it through modules 5 and 6 this evening. So. Um, that's our goal, lofty goal, but I think we can do it. Did everyone make it through the labs okay last week? Any questions or issues with them? They were all pretty straightforward, really. Still working on them. Okay. Well, and like I said, this isn't a college class, right? You're not going to be graded on them per se. They're really there for you to get comfortable inside the Android operating system and developing apps on them. So I would almost indicate you can do them at your leisure. I'm not checking them for a grade. That's for sure. Right. No worries there. I know life happens. Okay, so I believe this is where we left off. Um, it sounds like Matt may be on babysitting duty. So uh, let's see. Let's try this. Um, maybe all right, let's see. We'll mute Matt for right now until he gets off babysitting duty. Okay, so where we left off with intents and the reason for intents and how to ensure that we're closing loops, if you will. Uh, the intent, right, or the intent recipient, right? Once again, pay attention to the highlighted chapters or highlighted words within the slides. Those are the ones that I'm pulling out for you that are good testable material for when you go and take the exams. Um, Chapter 4, or were there some for chapter 3 as well? Okay, so no. Paul, there were only, I think there were 3 labs for chapter 4. There weren't any labs associated for chapter 3. Don't worry about those. And then this evening there will be, I believe, a lab for chapters 5 and 6. Okay. The intent recipient. Once again, we're looking at the activity, or the intent of the intent, if you will, right? So depending on who you want to receive the instruction, you will identify with the appropriate flag or text, right? So the intent recipient, if it is a specific activity, start activity with activity in the camel case, is how you will launch the new activity. It does not receive any information back. Fire and forget it activity versus receiver or uh, once again, you're looking for some sort of reciprocal action. These are the receiver intent is for broadcasts, right? So whether you're broadcasting, send broadcast with intent. Right. So once again, you're looking for a subsequent code that continues while the receiver runs, or send broadcast. Right. So only the receivers with the specified um, receiver permission can receive the broadcast, right? So anyone else that does not have, for instance, the matching signature will not be able to receive that broadcast. Data can be returned back from the broadcast when you use the receiver intent or any of the broadcasts. Remember, it is suggested that you shy away from sticky because essentially it does have weaknesses that allow attackers to circumvent uh, the broadcast intent, right? And so since it only can be information returned back during the broadcast, you want to make sure that the broadcaster, the recipient, is actually who was designed to receive the broadcast intent. The service recipient, right? We're using the intent to service. Once again, it requires that the service be started. So you would use activity first, start activity to launch the activity, and then move to start service to then begin executing. Okay. Um, and these next series of slides are really just highlighting, for instance, that the correct text or the correct nomenclature used for the design or intent of your applications. So you see, you have the activity intent, starting the activity itself. It can be exported. That's why I've highlighted there for you true. The receiver has full privileges to it, right? Full privilege to read sales data and then to update the sales data, and they're using the package. The entire package is the scheme. Okay. So that brings us to the APIs themselves, and some APIs within the Android ecosystem are protected APIs. If you remember the beginning, I believe it was maybe module two. It showed you essentially what functions were down there at the core, or at the heart within the hierarchy. So camera functions, GPS data, Bluetooth and telephone, SMS and network data. Those are all protected by specific permission within the hierarchy. They're closer to the core, if you will. Though that is important to keep in mind, especially when you start calling on services to start, that you are actually calling into the root level of the operating system, and once again, it's very important to identify, for instance, where that broadcast is going. Make sure the broadcast is received by someone using a signature or root level permission to ensure that you're not allowing for or, any other additional vulnerabilities. Once again, so here's a snippet of code that is just highlighting that for you, right? To enforce the permissions or special accesses as you call for action within the protected API scheme. Okay. Okay, so important to understand that not all permissions are made equal. I guess I should say, depending on the versions that you're running, uh, they will either be inherited, or you will actually have to then call out specific permission. Android 1.3, for instance, writing to the SD card without write external storage was permitted through the evolution. The app developed so the Android 2.3 cannot write to the XT card unless you expressly permit write external storage. And that's going to be very important, especially in the next coming chapters when we start talking about special permissions to external media, and how to protect the data that you're writing to external media, and the types of encryption that you choose or use uh, within that decision set. This really, all this is doing is highlighting for you to be version aware. So as you go through the software development lifecycle, are you going to have to update or your code to include the ability or exclude the ability to write to to write to protected or external media. So not all versions should be treated the same, and you as developers need to just be sure to be cognizant and aware of that. So temporary permissions. So temporary permissions, I guess it really is. I mean, it doesn't. I don't think takes a whole lot of explanation, right? I mean, the app has to have some sort of permission to do whatever function you've designed it to do. However, your approach to it, whether they be static permission or temporary permission, should be with at least within your consideration. Once again, you want to use an intent to request information from the app with the required permissions instead of, for instance, just assigning static permission where the app will be able to call at will. It should always be going through the additional check to ensure that the broadcast is received by the intended party, vice being intercepted, especially since you don't require response. That has to be paramount in your mind when designing the architecture of your individual applications. So yeah, so that brings us to the end of section 4. Like I said, it wasn't that much to do, but we were running long on time in the last sessions, and I didn't want to necessarily have to rush through that for you. So give me just a few seconds. I'll pull up the next module, and we'll get started again. Okay. So now we move into module 5. This is a module that some people find either extremely confusing and difficult, or some people extremely easy. So I guess with just a simple quick show of hands, encryption. Of the seven of you, how comfortable are you when it comes to the idea of encryption and how it works and when to use which type of encryption? Pretty good, decent. Okay. Okay, good. Good. So, looks like most everyone is fairly comfortable. Um, so at least aware. Okay. Okay. Good. Okay. Well, then good. So this should move fairly quickly for you. It's not a lot of new information. It is very much reinforcing, right? Especially if you've already taken the Security Plus exam. This is just kind of building on that foundation. It's not moving into the higher level understandings of especially this subject matter that for instance, the CISSP or the CASP might want you to have. Okay, so when dealing specifically with security through encryption, there are just a few things to ensure that we understand or we make sure that we take into account. Now that we've understood the various threats and the threat vectors that attack our apps and the devices themselves, understand that you have to keep the transmission mode in the forefront of your mind sometimes, right? How is this going to be transmitted? What type of encryption is even possible with it? Am I using TCP/IP architecture? Am I using Bluetooth? Am I going over LTE network? So I mean, these are all things depending on what type or level of encryption you're going to employ needs to be understood and kept in mind as you deploy certain types. Okay, so plain text versus ciphertext. This, especially with this group, I think is just nothing more than a review. Um, the important, the takeaway really here is that you can do one-way encryption, which is never going to be decrypted. Okay, or two-way encryption, which is intended to be decrypted. Okay, so depending on what your intent is, will definitely choose whether I'm going to do one-way encryption or two-way encryption uh, through each exercise. Uh, Substituting characters or transposing characters. Uh, Once again, this really should be, I think, reviewed for you guys. I mean, am I shifting characters around through some level of, okay, this goes three spaces to the left, and this one goes to two spaces to the right, or am I using a simple mono alphabetic approach where A equals Z and B equals Y or what have you. Maybe you just flip the alphabet around. Versus what we call stenography, right? So stenography is the practice of hiding in plain sight, if you will, right? Take a picture, you hide some data inside that picture, and that is the practice of stenography. uh, Vice using complex mathematical functions. That is what we'd refer to as an algorithm, right? So we're going to use some sort of encryption algorithm to hide or obscure the plain text of data. Whenever you're using any of those types, uh, first and foremost, right, the most important to protect is the key, right? The key unlocks everything, right? You knowing that I'm going to substitute Z for A, for instance, the key to that substitution cipher. So protection of the key is paramount, especially when dealing with encryption. Once the key is compromised, essentially the entire crypto system is compromised, and that means you have violated. Essentially, the C of the CIA. You can no longer assure confidentiality. Encryption is available in a wide range and varied strengths, depending on the overall intent or what is the requirement, right? All the way from simple 40-bit encryption, which we would probably associate most readily with web encryption, up to the current standard of 128 AES encryption. Now the government has moved, for instance, into 256 being the required baseline for encryption strength. Right. So once again, there's no right or wrong. It all depends on the ecosystem that you are going to employ it in. What fits best to balance the CIA within your own environment and your own organization. Uh, the stronger the encryption, obviously, the harder or the system or the system of systems have to work, which is going to slow down process and tilt your triad out of balance. You're going to bring down availability by using stronger encryption. But if the data is of such a sensitive level that it warrants stronger encryption, then I would indicate that yes, you've considered and you've balanced the triad. Okay, when we take a look at whether I'm using substitutions or stenography or one-way encryption or two-way encryption, the things that I'm looking for, for instance, with one-way encryption, generally I'm talking about a hash, right? I'm going to hash the data to come up with some sort of hashed value that I can then later run the same hash or run the same mathematical problem against to verify the integrity of that data, to make sure that the data was not changed in any way and it can still be relied upon. Then moving to two-way encryption, that's where the conversation starts coming in of symmetric versus asymmetric. Am I going to use symmetric encryption or asymmetric encryption or a combination of both? uh, what is required between the two? So symmetric encryption, just remember symmetric encryption is same or one. You're using the same shared secret key for the entire encryption mechanism. Extremely fast, however, extremely vulnerable. Right, symmetric encryption does not scale very well. So n to the two, right, is probably the formula that you've seen. Uh, issue is, anything that was encrypted using the same shared secret key, once that key is compromised, everything that was encrypted has to now be considered compromised. You have to rekey it all, versus asymmetric, which is using two keys, a public and a private key. Uh, Ensuring to a greater degree of certainty that confidentiality is being maintained. Uh, because once I send within an asymmetric system an encrypted message, that only the holder of the private key is going to be able to decrypt, then I have assured the confidentiality of that data. It does, and conversely to symmetric key encryption, it does scale well. Right, so just because one private key, for instance, may be compromised either through or attack or loss, I don't have to rekey everyone. Everyone doesn't need to get a new private key. So, however, the thing to consider with asymmetric, generally it's using a much longer key space, which is going to require more resources. Right, so it is a little slower, more resource intensive. However, the upside, once again, you can assure confidentiality because you're not sharing anything. You know who has the corresponding key to the data that you sent. Uh, so that's, that being said, remember, you don't have to choose a one or the other. It's not an A or B. Uh, Sometimes the data warrants a mixture of both symmetric and asymmetric cryptography, right? So, for instance, if any of you work within the federal space, or especially the DoD, the DoD CAC, the way we send email signed and encrypted is a mixture of both, right? There's both symmetric and asymmetric, depending on the volume, if you will, the size of data that you wish to send. Obviously, we prefer, because it is fast and it is efficient and it's really good for bulk messages, that symmetric encryption be used when uh, sending, for instance, PowerPoints. Right, I would want someone to take a 9 meg PowerPoint, send that uh, via symmetric encryption, because I don't have to utilize a lot of resources to decrypt it. However, smaller messages, just a simple text in the email, can be sent with asymmetric encryption. So I'm going to wrap both of them together for the efficiency of it. And there are some other examples where we could pull different parts of it apart as to when to use which, but that's kind of the understanding or the takeaway that you need to understand. That it's not an A or B, it's not a one or the other. Okay. What are some of the cryptographic standards? You're probably most familiar with, like I said, AES encryption. That is the standard encryption used by the federal government and the DoD. 128, 192, 56. So I'm not going to really indicate that you need to spend a whole lot of gray matter committing all these key spaces to memory. Because once again, this is a tag on to Security Plus. They did that in the last exam. This is just kind of a reiteration for you. Okay. Saber Cipher. Saber Cipher is one of those newcomers, right? You see it especially a lot within mobile computing, right, and mobile devices, because it is very easy to implement. So beginning programmers or new app developers can employ or balance the triad by using some sort of encryption, without having to deal with a lot of the complexities of some of the other more complicated ciphers, right? For instance, like Two Fish or Randall, right? So Saber cipher, I would probably indicate should be at least 1 or 2 points for you, for no other reason than it is it's extremely easy to implement, and it's easy for beginners. Okay, DES encryption. A lot of people indicate that DES is gone. DES very much is well and live and kicking. We use DES a lot within different environments. Once again, it really just depends on the sensitivity of the data that you're dealing with. It has, for mass use been superseded, or by triple des or three des. However, once again, des, you still see des in use a lot throughout all industries, whether it be federal or commercial space. It just really depends on the data that needs to be encrypted. So understand here. So, and I made a note here for you that the X509, that is not an encryption standard. That is a standard itself. It's the standard of our certificates. It specifies a standard format and what information the certificate must hold within the cryptographic system. Right. So X509 is a standard, not any type of encryption. So. To me, it was kind of confusing to see it here, but that is really all that you need to really truly understand about X509. It's a standard of what their certificates must look like, the information that it contains, and how they interact with each other. Uh, Most importantly, I would probably say to the Android system, because it is primarily based on open source methodology, is OpenPGP. OpenPGP is asymmetric public key cryptography that is different from, for instance, what is used within the federal space. Okay, so OpenPGP it does not, it meets all the requirements of public key, but it uses a different philosophy, and we'll get into that. We'll get into that here shortly. Primarily, you're going to see OpenPGP for email. Right, so when you're sending and receiving email, going out and getting yourself an OpenPGP key, like I said, it's an open standard. It's freeware. You can do it for your Gmail if you so choose, or you need that level of protection within your own private email. Right. So PGP, pretty good privacy, is exactly what it was, right? Or is, I guess I should say. OpenPGP is just the open source standard of it. So be cognizant and aware that PGP is not the free version of it, right? You'll have to pay for licensing for that. However, OpenPGP is freeware. Okay, the difference, the primary difference between PGP and the federal space, and what they use on CACs, are the difference between the hierarchy. PGP lives within a web of trust, and so the web of trust simply is, I trust Bob, Bob trusts Jane, so I trust Jane. Right, so that's how the web of trust works, and that's what the entire PGP standard is based on. So you don't need the hierarchy of a CA and an RA, to issue certificates and revoke certificates, and investigate validity of individuals making requests. Right, it's all based within a web of trust. Right, so that's the takeaway for you for PGP, vice any other cryptographic system. I'm not knocking either one. How I use PGP or OpenPGP for some of my personal correspondence, like for instance, mailing my tax stuff um, to my tax lady. Right, I don't want to send it, in the clear, so I have an encryption key that I'll send stuff like that with. Okay, so that's it has use in both commercial and private space. Uh, so the certificates that we deal with, What are the certificates really? So the certificate is your identity, right? It is who you are. There are two parts to you, right? And some might say there are more than that, but for this discussion, there are two parts for you. There's the public part, and then there's the private part. So the public part would be considered your public key. Everybody should have access to your public key. That's why they tell you, okay, so when you get your new certificates, publish them to the gal. What they're telling you is to send your public key up so that everyone can have access to it. Certificates are held by both users and the device, right? So within a large enclave, right, you might get a soft cert for a server, for instance. Uh, Boil it down into a mobile device, you would want to associate a key with that device. So and pair that device or that your application, for instance, with a public key where each user would then get assigned a private key uh, for use of the application. Uh, it works within a hierarchical system with a certificate or authority or a CA, right? So you're going to sign your app right before publishing it to the store, and that is how when we talked about make sure the signature is required for your broadcast. That's essentially what it's doing. It's looking at the signature of the app developer and making sure that that is the only trust that is associated within the uh, within the enclave, or in this case, within the mobile device itself. Okay, so that makes sense. This all pretty much still just review for you guys, correct? Not a lot of new stuff here for you. Okay, good, good. I definitely don't want to bore you bore you to tears with encryption. Some people like it, some people don't. Some people just tolerate it. That's for sure. Okay, so we're coming up on our first break. At this point, we're going to take a pause here before we get into hashing functions, which once again just encryption just in one direction. So we'll take 10 minutes here, and we'll be right back. All right, we all back. Got our fresh drink, or I don't know, maybe put dinner on, or make sure the kids aren't setting the house on fire somewhere. Whatever is important at the time. Okay, so we've gotten up to hash functions, and what are they, and what is their importance? So remember, hashing is considered a one-way encryption, right? It's never meant to be decrypted. All you're trying to do is provide overall data integrity assurance to the receiver. Right, so the basic rules that hashing or a hash algorithm should follow. Uh, First, an attacker should never be able to generate data based on the hash value, right? So we would call that having pre-image resistance. Okay, so not being able to reverse engineer to get data from a hashed value, that is the pre-image resistance. The attacker should not be able to modify data without it also changing the hash value. So that's what we would refer to as the second pre-image resistance. Okay, so try to keep them straight. Not be able to discern data from a hash value. That's pre-image resistance, or alter data without also changing the hash value. Second image resistance. The two different data values should not have the same hash values. That's an easy way or a hard way of saying two pieces of data text should not uh, give you the same hashed value. That is what we would indicate as a collision. I don't know if you're familiar with the birthday attack or what have you, but essentially a birthday attack, you put more than 20. I think it's 20. It might be 30 people in the same room. You will find two people with the same birthday, right? So we would identify those two people with the same birthday as the collision. That's what we're trying to protect against when we choose a hashing algorithm, and that's why you see the iterations of hash algorithms as weaknesses are found. They'll move right from SHA to SHA-1 to SHA-2, SHA-3, so on and so forth, right? Because they found a weakness, they found a possible instance of collision, and so they moved to make the algorithm stronger. Next, when after dealing with hashing, we deal with how do we protect the namespace or the password space. We do that by salting, right? We'll salt the password. Essentially, it's a randomly generated or pseudo random. We're not going to get into that argument. Number. Stored within the hash value itself, so that the system or the ecosystem knows what that pseudo random number was and where it placed it. However, the attacker would not know what is the salt value versus true hash value, so they would never be able to reverse the hash to attack against the preimage itself. Okay, this is extremely good mitigation or countermeasure against rainbow table attacks, right? So, salting passwords and salting the password space within the hash value, it would be considered a countermeasure to rainbow table attacks. If you're not familiar with what a rainbow table is, essentially it's just a large dictionary of hashed values based on words that you would then run against a password file, hoping to crack the password file. So obviously, yes, this is, by adding salted values, you're adding length and complexity to your overall password, which is the goal, right? Passwords generally are the keys to the system or keys to the kingdom. So we want to protect those with as much complexity as we can, and obscure, security through obscurity once again. Salting within web apps itself protects against SQL injections, right? So one of the ways, because really all the SQL tables are just flat text tables, you're looking for a way to protect the backside flat text table against the brute force attack of a dictionary attack. You would salt the entries, so it protects against, for instance, dropping the table somewhere, right? So that is salting when within itself. Once again, I don't think this is new stuff for you. Yeah, if you've executed the security plus, this at this point is still kind of a review. Key stretching. So, what is, in fact, key stretching, right? Simply put, key stretching attempts to take a weak key length and make it stronger by increasing the time it takes to test the possible key values, right? That is in itself key stretching, right? So, hashing each password. Essentially, when I stretch the keys, or I add additional value to the key, I'm in theory causing the attacker to use additional resources. The goal is not to make it unbreakable, but only to make it so resistant that the resources of any given attacker, it would not be beneficial for them to expend the resource against the asset, right? And remember, resources are identified as three levels: time, people, money. So that is the goal here: is to make it not worth expending the resources against. Right. So if you want the technical bits and bytes of key stretching, or I don't know, has anyone here not ever heard of key stretching, or what it is? Is this new to anyone? New. Okay. All right. So a couple people is new to this. I'll give you, I guess, the Tencent tour around it, right? So how do you perform key stretching in general, right? Without getting way deeper than we need to for this level exam. The initial key itself is fed into an algorithm, and you essentially choose your algorithm, whatever your encryption method is. That then will output an enhanced key. Right, that's what we're looking for. So, the initial key. Remember, I said the key is the key to everything, right? It's how or the crypto system works. So I'm going to take the initial key, feed it through an algorithm. It's going to give me an enhanced key. That enhanced key needs to be of sufficient key space. So once again, I wouldn't want it to give me a key space of 40, because 40 is considered too weak. Modern, laptop, computers, my child's netbook has enough resource or processing power to break a 40-bit key. I would want to extend that key length up to at least 128, right? At least the pseudo modern standard. That is like I said, the 10 cent store, 10 cent tour of key stretching. Take the initial key. Let's just say it is a 40-bit key. I'm going to shove it through an algorithm. It's going to spit me out, based on that algorithm, a 128-bit key or a 256-bit key, and that is what I'm going to continue to use throughout the ecosystem. So that's how I can get away with, once again, like I said, using DES, which has a very small key space, 50 was 56 bits if I remember correctly. Um, I'll use key stretching. I'll plug it through another algorithm, turn that 56-bit key into a 128-bit key. I can still use the DES algorithm and accomplish the same end state or the same goal. Okay, so that's key stretching, kind of 101. All right. Uh, so, um, passwords. So with mobile devices, you get into kind of a new set of vocabulary, or at least introduction of new vocabulary when it comes to passwords. We generally don't associate, for instance, password with encryption. The encryption is the design, right? It is the thing, that mechanism that I'm using, the algorithm to obscure data. However, with the advent of mobile devices, whether they be tablets or phones, you have this concept of a keychain, right? So when we talk about password-based encryption, we have to be cognizant that there is this thing called the keychain that can store values, right? But is it really, what is it really storing? Is it storing the password itself, or is it storing the key derivative of the password? Right, so essentially that's what the keychain is doing. It looks like it's storing your password. um, that's not what it's designed for, right? It's not designed for username and passwords. It's key derivation, right? It's derived, the key is derived from the password. The password is stored in the key space, and I'm sorry, in the keychain, and that is the concept, or the goal of the keychain. AES has become kind of the default standard for encryption. When it comes to password based, if you will, encryption, is using AES 128. However, that can be changed through some effort. It does use salting. It does use key stretching. So the keychain should not be, for instance, shied away from. It should actually be encouraged with the right education and the right mechanisms behind it to ensure safe employ of how credentials are being stored. Um, so the app itself natively is not encrypted. That is not a um, a feature that comes with the free version of applications. Once you put a price tag on it, or 99 cents or 199, 29, whatever, that is where the Google Play Store offers free encryption for those fee-based applications. Uh, However, it is for Android 4.1 or later, right? So take note of that. Applications for a fee are encrypted, or at least offered to be encrypted on Android 4.1 or later, and the app's binary is encrypted. So those are all very key points to take note of and to be cognizant of as well. So the LVL, or the license verification library, it includes classes to help the developers when implementing the licensing of apps. For instance, you let the downloader use the application for 30 days. Yeah, that is where the time space, the time is identified, is within the LVL itself. Um, the But bear in mind and understand the LVL can be reverse engineered, right? So you can decompile and overwrite the licensing itself, so that should not be um, counted on for overall application security by any means. Okay, so just make sure that you have that clear. Okay, so uh, now that we understand or are cognizant of application encryption, what it is to salt the passwords, providing a large key space, one-way versus two-way encryption. Uh, Now we can get into, I guess, a better discussion on how do we protect the actual data itself, and for instance, the databases that are housing that data. What we indicate, right, when we talk about the encrypting and hashing of database data is we're encrypting multiple layers. Okay, we're limiting the overall attack surface. We're not making any one layer too difficult to circumvent or overcome. However, once again, the attacker would have to spend far more resources to overcome all layers. We can use different strengths and algorithms and hashing versus true encryption on backend data to our advantage, and not overwhelm the resources of the device. So by doing this, we can implement basically what is identified as key management, right? Key management, you think of once again, asymmetric encryption. You have a public key and a private key. Uh, the the keys are separate. So it takes multiple keys to unlock each layer throughout the database. You cannot get to one without the other. Sometimes I kind of begin to think of the Russian doll, right? It starts as a big doll, the size of a football. You take off the top, there's a little one inside. You take off the top, there's a little one inside. I have to know the key. The key is the fact that I need to know to take off the top to get to the next layer. Okay, that is kind of key management within a layered database structure. device hashing it. So I'm going to apply a hash to add a little more security. But remember, like I said, the security of hashing has nothing to do with confidentiality of the data. That's not its design. The hash is there to provide a surety, or a level of integrity that the data has not been altered. So that's why we'll hash the credentials so that they're not exposed within a SQL injection. So then the attacker doesn't gain uh, my credentials to unlock the next layer of the sensitive data. Okay, does that make sense? It gets kind of confusing when you start dealing with the layers, but really, once again, for testing purposes, the way to kind of keep them pulled apart uh, is the implementation of key management, right? Keeping separate keys away from the data. So I have to go over here to get this key, and then I have to curry it over to the database to unlock the next layer, and each credential is hashed uh, rather than kept in a plain text file on the back end of a SQL database somewhere. Okay, so uh, once again, if you can keep those two items straight, you should be just fine for the purposes of this examination. Okay, so we all still with me here. Once again, when I get to something new that this isn't just pure review for me, by all means, let me know. I'm more than happy to slow down at that location, but I don't want to just hammer on stuff that you guys already have committed to memory. Sometimes within the database or the data store, uh, the key management it just isn't feasible, right? The device doesn't have enough power, it doesn't have enough resources. Maybe you're dealing with an older device, uh, so you just don't have that option for yourself. So what's the next best thing, right? So the next best thing would be implementing at the file level versus the database level. Remember, we talked about security being defense in depth, right? Defense in depth is layers of security. I start at the outermost and work myself in until I can assure the data has met either the confidentiality, integrity, or availability required. So if I can't use full database encryption, I move into the file space, right, and encrypt the file space. I do that in the keychain API. Uh, that stores the keys and certificates for the apps to share uh, across the entire environment, right? The environment being that device or that series of devices, or talking back to your database, for instance, to share encryption services. Um, right now, within the Android platform, it's limited to RSA public key encryption. So we talked about some of the downfalls or the faults of public key encryption. We have issues with scalability, right? So one is compromised, all get compromised, right? Or at least all data encrypted with that same key. It doesn't work with symmetric encryption. Symmetric, two are the same, right? A shared secret. So the keychain API itself um, is kind of once again limited to PKI. Um, However, it's using what most would, or many, I wouldn't say most, many would indicate as one of the weaker algorithms. Um, However, I often indicate, some encryption is better than none, right? I'd rather encrypt with the weak algorithm and take my chances than not encrypt at all, right? So just kind of keep that, kind of keep that in the back of your mind. Uh, of course, you want to avoid, if at all possible and where all possible, the storing of the keys on the device. Right, make make the device have to call to a remote location or a remote service to capture and implement the key. You don't want to store those credentials or those keys on the device itself. But once again, I think that really becomes a little bit of common knowledge or accepted practice a little bit. Um, So, so moving from database encryption, outermost layer, into file level encryption, it goes to saying that the entire device itself can be encrypted. It uses decrypt. So decrypt. Once again, if you've lived in the Linux world for any amount of time, it's fairly commonplace. If you have not lived in the Linux world, you should get yourself familiar with decrypt. Essentially, decrypt is a transparent disk encryption system. Excuse me. Um, it is the subsystem is available or only available in the Linux kernel versions 2.6 and later, and then Dragonfly BSD. So I point out Dragonfly BSD for you for no other reason. I don't know if you're planning on taking, for instance, both the Android and the iOS course, but Apple in the Apple iOS is based on a BSD design, so that kind of lets you know that there is somewhat of a tie-in in there. To enable DNMencrypt, so the nomenclature for it, all capital letters, config, CONFIG underscore DM underscore encrypt, all capital letters. That essentially enables the full disk encryption within the device itself, as long as the RAID or the LVM is available. Okay, so um, are there any questions there about DM encrypt and where it is and what it does? Okay, good. Okay, so a quick review for us. Where we started versus where we are. Um, how to choose the right encryption. Uh, Long keys, good. Short keys, bad. Right, so that's pretty easy to remember. Uh, Always want to compress the data uh, prior to encryption. Don't make the algorithm run through a large data set to employ the encryption. Remember the PowerPoint, right? I'd rather you compress it first using symmetric key encryption, and then wrap that message up using asymmetric encryption to conserve resources, essentially. Uh, Long, complex passwords. I think that's been beat to death with this. Does anyone still have a password that's password still? Am I the only one? Okay, good. Be cognizant of your network traffic, right? So you should always default to using or encrypting network traffic via SSL. This test is not getting into the differences, for instance, between the SSL versions and then the switch over to TLS. So for the purposes of this exam, you essentially can treat SSL TLS as one and not necessarily putting a lot of gray matter behind. Am I using SSL version 2 versus version 3 versus TLS version 1 or what have you? Employing hashing and ensuring you're employing hashing with high resistance, right? Minimal or no collisions is what you're searching for. Implement the key stretching, larger key space, more resources have to be expended, and increases the overall security of the passwords. Um, And so that, that is in a nutshell, exactly the guidelines, right, or the steps or the check boxes as you work through selecting the right encryption. Okay. Um, okay. So specifically, now we have an overview of encryption and hashing and salting and key stretching. Uh, Dealing specifically within the platform itself and the Android API. Once again, you're going to see all very extremely Java based. So the same Java vulnerabilities begin to take place, or at least you need to be aware. Um, uh, Here are the specific values for employing the Android cryptographic APIs that you're going to inherit from the Java APIs. Uh, of note here, and I think I missed highlighting it. It looks like I missed highlighting on this slide. The encryption API support both symmetric and asymmetric, and it repurposes castle into spongy castle. Okay, so on your notes there, highlight those two. Supports both symmetric and asymmetric, and repurposes bouncy castle into spongy castle. Those That's real good test fodder, if you will. Should be worth at least like 1 or 2 points for you on the exam. Um, Okay, so within the Java cryptographic architecture, once again, you're dealing with very specific nomenclature. However, the concepts remain consistent and remains the same. You just need to know when to employ what and what each is employing. Of this list that it is identifying here, I would probably indicate the uh, only one that might trip you up or two, I guess it would trip you up, would be the message digest and the Mac. Um, uh, I don't know. I don't know how long ago you took the Security Plus or what have you. Did they have Message Digest and Mac on the Security Plus when you last took that examination? It's mostly Windows. Okay. All right, so some people yes, some people no. Okay, so and I do know that it has gone through more rapid revisions as of late. And once again, the newer tests had Message Digest and Mac. The older tests didn't. So it looks like most everyone here took the new test. So that's good. So we won't spend any time on Message Digest and Mac. Um, so really now so that's good. So you can concentrate on ones that are type specific to the Java platform, which secure random. For instance, I think that kind of answers itself. It generates a pseudo random number versus the cert path builder. Once again, pick a name that has meaning. Uh, I think you can pull out cert path builder. What is it doing? It's building the certificate chain for you, right? So even on a Windows machine, you open up a digitally signed message, click on the certification, I'm sorry, the sender cert. It'll show you the entire path of the certification uh, within the Java platform. That is the cert path builder wrapped in to the cert path validator. Okay, so when you click on it, it shows you the path. It's putting either a red X or I think maybe a green check mark next to it to let you know that yes, this certificate is trusted. Yes, this certificate is trusted. This one cannot be verified. Right, so put an X on it. So the good part is the names within themselves are very intuitive. Right? You can pull out from them. The only one that most people have problems with, like I said, was Message Digest and Mac. So good. It looks like you guys will be okay. We'll be okay there. Okay. Um, Once again, this is really more content for you than context. It's not. I don't see a lot of people coming back and saying, we had this on the test, or they asked me about the key agreement and what it did, and what have you. I'm just not getting a lot of feedback in that direction. So once again, more content than it is context for you within these next couple slides. However, absolutely, give it a peruse through. Kind of acknowledge that you see it, but there really are more important items or concepts to deal with for this certification specifically than dealing with or trying to deal with this exhaustive set of what it is and what it does within the architecture. Okay. Okay. So this, however, is some good information for you, especially for testing purposes. Uh, you've noticed, I'm sure, CompTIA loves acronyms. You'll see JCA, or at least you should see JCA. They're referring to the Java cryptography architecture. Once again, bearing in mind it's supporting both symmetric and asymmetric encryption, so fast and slow, good and not so good. However, you can best fit in your head, I guess. Really, um, the key advantage to this, however, is it's indicated that it integrates seamlessly into and with third-party vendors. Um, Now, I don't know the experience that you guys have had with Java. Um, However, my experience with Java has been anything but, for instance, seamless. Um, However, for the 90 minutes that you're in the exam room, forget what you know and think about what they want you to know, and think of Java and the crypto system, or the Java cryptography architecture as seamless integration with third-party vendors, and you'll be and you'll be okay. Okay. So that's really the takeaway and the highlight from here, and kind of what you need to know and be able to pull apart. Um, so when I say symmetric and asymmetric, go find, for instance, the question set has, AES is being employed. Um, uh, what also may be employed within the Java cryptography architecture, they may only give you another set of what looks like for instance, symmetric key encryption, or they'll give you one symmetric key encryption and three hashing encryptions. Uh, so essentially, what they're trying to pull out of you is your understanding that Java is going to support both symmetric and asymmetric, being AES, and pick your flavor of symmetric key, whatever suits your boat. Okay. Okay. Um, I feel like I've gone long, but I guess I haven't. Okay. Okay. So keys are. So what is Keyzar? Why is it important to you? Once again, it's based on an open source standard, which is the Android platform. So I would suspect that you are going to see Keyzar, if not once, several times when dealing with the encryption portions of this examination. Um, so the basics of keys are uh, there's a number of mistakes, right? The developer can make when adding encryption to his apps, right? He may choose bad algorithm, uh, bad cipher modes, poor key management or poor key rotation. What keys are is doing or is designed to do is to provide a kind of a check valve for these, right? So you make a mistake as the designer of the application by implementing Keyzar within the ecosystem. It's your failsafe, or supposed to be your failsafe for making some of these mistakes. Um, the output, right, of Keyzar, there are just certain principles that you need to bear in mind, right? The design philosophy behind it. uh, it's all all the output is signed by default, right? So that's a good thing. um, all output and key formats, um, uh, simple to extend, right? So once again, when we talk about keys, key and extending keys should be correlated to very good things. The API itself does not expose the raw key map, so that it's keeping obscurity, right, or security through obscurity uh, within how the API works, to ensure that the raw key material is kept hidden. The only thing that you then later see is the stretched key. So once you can see the countermeasure to some of the bad decisions, or maybe we just don't know type decisions made when it's centered around cryptography. Keyzar is designed to try to be that check balance between the two of them. An important point of note: it's meant to support the encryption libraries, not replace them. Okay, so it is not there to be, for instance, truly dependent on um, for encryption, right? It's a support mechanism. That it's not there to replace the encryption algorithm or library itself, and not all applications are going to work with Keyzar. So this is where the test and retest through the software development lifecycle begins to come into play. And if you are reaching out and needing to hook into another app within the device, you're going to need to test. If you're choosing to employ Keyzar, you're going to need to test against that device to make sure that it is supported for your intent. Okay. Okay, so secure video. More and more the devices, or we're asking more and more of our devices to do things. It used to be, secure email was the end all be all, and then okay, so now enter, Tiger Woods and his issues. So now I need to figure out a way to encrypt my text messages, and then you move into, since our workforce is constantly mobile, now I need to ensure secure video. There is an application designed by a gentleman by the name of Phil Zimmerman. It's called Silent Phone. Essentially, the whole premise of it is encrypting the entire ecosystem of the phone. I mean, there are add-ons for Silent Phone, for mail and for text and for video. Phil Zimmerman employs a system identified as Zimmerman Real Time Transport Protocol, or ZRTP. Uh, yes, I would expect that Phil Zimmerman, in some form or fashion, is going to be on this examination. If nothing else, uh, they like to play with his name. So identify Phil Zimmerman with secure video call and silent phone. However, silent phone, it should be taken note of, is not open source. It's not free. It is a paid service. So for CompTIA to maintain their vendor neutrality, they can't harp on too much, other than asking you to identify, for instance, Zimmerman with secure. video, or Zimmerman with silent phone. Okay, so can't get they can't get too deep into it because then they have issues with their neutrality or vendor neutrality that this examination requires. Okay, so that brings us to the end of module 5. Fairly quick module to deal with. I guess the good part is mainly because, like I said, it's a lot of review for you, not a lot of new information there. There are 2 labs associated with volume 5. Uh, both of them. You can find in this website. Securing data through encryption uh, is no, I'm sorry. Securing data through encryption is lesson 5 or module 5, and then lesson 6 or module 6, where we're going to next, will be accessing data. So that will be next up on our list. We're a little ahead, but I guess ahead is better than behind. So I'll tell you what, let's take a short 10-minute break here. I'll load up the next set of slides. We'll move on to module 6. Okay. Okay. So we should all be back. I think quick 10 minutes. Um, hopefully you got some time to get through whatever you need to between these breaks. And looking forward a little bit. Um, this is not a long module at all. Um, so we're actually doing real good on time. We'll have kind of somewhat of a decision to make. Um, this module itself probably only maybe an hour, um, and that's with 2 breaks in there, which will take us right up to probably like 7:30 or so. Um, uh, we'll have a decision, like I said, to make whether we want to work ahead to another module, or maybe you guys have family things to get through. Um, that you need to get to the day after Mother's Day. We can be cognizant of that. So kind of keep that in the back of your mind as we work through this module. And I always let the mob rule, right? So whatever you guys feel is best for you, I am more than willing to uh, join in. Okay. All right. So module 6, I believe, is where we're at. Accessing local storage securely. It's one thing to be able to access the storage. It's one thing to be able to read from and write to the storage, but how you do it in a secure manner seems to be what's missing, or that piece that some app developers forget. So, what we are going to primarily be focusing on within this module itself is identifying the types of storage available to you, whether it be internal or external storage, whether you're using XML storage, or SAML in some cases, possibly using single sign-on, for instance, or the SQLite databases, right? So that is the focus of this module in itself, knowing what the countermeasures are or mitigations towards some of the threats of local storage or extended storage, whether it be an SD card or what have you, and then how to implement secure access across the enclave or the device, as you will, to ensure your app isn't the app that is leaking overall data. Okay, so when we start thinking about storage and types of storage and what is available, obviously internal storage is going to vary from device to device, how much you have versus how little. Um, However, they all have the same kind of makeup, right? Uh, the internal storage itself is what is providing that sandboxed environment for each individual app to run in. Each app is allocated its own private space. However, bear in mind that internal storage and files and sensitive data stored inside internal storage loses its protection when the device is rooted. Okay, external storage, SD cards. Not protected by file permissions, right? So you can implement file permission within the internal structure, the internal storage structure itself. However, the SD cards that can be and most often are inserted into Android devices, that same protection is not extended through file permission for external storage mechanisms. Shared preferences, XMLs. So you're dealing with a key store again, and key values and data pairs within the XML pair being identified. The XML database is identified as a type of storage. That's why it's included into this discussion. uh, Storing those strings, right? Those strings of data and file resources in the res folder or the resource folder. Uh, Understand that the resource data application can be extracted and often is extracted when employing the APK tool. Right? We talked about the APK tool in Module 1. And then the SQLite database itself, it's providing a structure, right, like a good database should. Um, the entire database is within the single file system that you're going to find locally, right? So bear in mind that by default and natively, information is not obscured or encrypted throughout a database, right? Even a SQL database. So as you call to and pull information from, you need to ensure that you're using secure mechanisms across the ecosystem to make sure your application is not leaking data. So that kind of moves us into the directory structure itself. Those of you that are lifelong Windows users are going to find the application directory structure within the Android ecosystem confusing at first. Those of you familiar with Linux and Unix should be kind of old hat for you, right? You're seeing a lot of the same um, words and names for within the directory as you do within Linux, right? The lib files, cache, shared preferences, they're all there, all accompanied by a backslash to move from directory to directory. You're dealing with read write permissions in multiple levels, all identical. You'll see them annotated as you do here, right? With a simple screenshot of the contacts file structure with DRWX, read write, execute. Each system or each section sectioned off in threes is telling you what that user or identified user, whether it be the system and administrator user, has permission to do within the file structure and to that particular file itself. Okay. What are the type of data that we're dealing with here? We've touched on it several times. I think it bears a little bit of repeating. We're not going to go all the way back to last week, um, but it is wide, it is varied, and all with different, clearly identified sensitivity levels, whether they be contact information or email, access into social media sites, photos, personal photos being stored, your search history through whatever browser is being used, storing your favorites, right? GPS location and coordinates. Lots of different types of data, once again, with all different levels of sensitivity, which is kind of I would indicate why this type of instruction um, is made available to individuals uh, to learn how to be able to interchange and access these types of data securely within a more secure environment. How do we protect this data? It all comes down to, okay, what does the device do for me? Well, the base operating system, and then what do I have to do as the developer versus maybe the Java language itself. Is it adding additional levels of protection for me? When you're dealing with the Android OS itself, what is it truly providing? Um, it is providing some level of protection to the application as it lives on whatever device, phone or tablet or phablet or whatever. Uh, However, that's kind of where its boundary ends. It's not extending the boundary out to external storage. So, kind of just put a check mark next to that. Okay, so that's something I got as a developer. I have to take note of. The OS is going to give me certain store or certain protections. However, the external storage is not. It can be shared. The base privileges and protections can be shared among multiple apps if certain conditions are met. For instance, the apps are sharing the same digital certificate. Uh, we would indicate that the same developer you have the same application. We look at this through all the different Google apps, whether it be Google Mail or YouTube or Google Docs. All of those applications, while individual and coming within the suite, should all have the same digital certificate as the root developer, in that case being Google. Uh, it does require optional settings to in the app manifest, which is, I believe, what we spoke about on Tuesday. uh, these extended protections are not afforded by default, right? They are flags that must be intently thrown. They're not there for granted. Okay. So those are the things kind of to keep in mind. Users and apps can use, for instance, the same ID, user ID, the same passwords to access multiple apps. You would do this. Lots of different cases, right? Whether an app developer is trying to provide some sort of single sign-on capability, or just conserving resources, or as you see here, right? The two versions of the same program. I have a free and a paid version. I want the paid version now that the user has decided to commit their 99 cents to my application to be able to have access to the data already stored in the free version, right? A good reason to allow for the sharing of data across multiple applications, or as part of part of a suite, right? Like the Google apps. Lots of good reasons to do it, but however, as we indicated, the more complexity you add to it, the more things can go wrong, and ultimately, a more complex ecosystem makes for generally speaking, a less secure ecosystem. So now that we know what the device will provide within its boundaries, now we know a little bit about what it's not going to provide. However, even within the mobile device itself, right? So out of the box, yes, it comes with these certain privileges and protections. However, once you root the device, kind of all bets are off, right? You cannot assure security once the basic protection profile has been breached. Essentially, a rooted device is circumventing all baked in goodness, right, of the Android operating system itself. File system permissions have been circumvented again once on these on the rooted devices. SD cards inherently just can't be protected. They're not designed to be protected. They're designed to be shared. Um, so that is something to keep in mind. Is users are extending data to the SD cards to extend capability or capacity to store more and more data. So, um, but inherently, that's not what an SD card is designed to do. It's designed to put the data on it and then move it to another device. If it's carrying file permissions from that original device, when you move it to the second, make it hard or impossible to access the data on the second device, right? So that's kind of a real good reason why the base operating system or the default operating system is not extending these file permissions out to mobile resources. Um, so I didn't highlight it here because I think it goes without saying, but it is one of those things. One of the largest threats to data is essentially the user themselves, right? They don't back up their stuff, right? Yeah, I'm sure we've all worked with somebody who went in, basically DEFCON 4 because their system went into complete meltdown. uh, you ask them, okay, well, no worries, we'll just reload the system. When was the last time you backed it up? And they look at you with that blank stare. All right, yeah. So, how many of you have had that happen to them in the last month, or 2 months, or 3 months? Am I really the only one that has to deal with that on a more regular basis? Nope, Steve. So all your people actively back up their stuff, right? Never lose any data. Okay, well then good. Then you are 2 steps ahead of the 2 steps ahead of the game if you are dealing with such responsible users as that they're always remembering to back up their data. I am not so lucky. On the other hand. What does it take, right? What does it take to ensure security, to ensure privacy, with all of the nastiness that users are doing to their phones voluntarily, right? Or I guess I should say their devices voluntarily. Once again, when you root the phone, it is actively circumventing all protection. Um, and inherently, the app is using the ability to isolate itself as part of its baseline protection. So when it's being circumvented like that, what you are using as a baseline for secure data transfer and secure data access is being violated. Okay, so you will notice, and you should notice on through your testing materials as you study. This is a point that is constantly kind of just pounded home, right? Is the dangers that you have to be cognizant of with rooted devices, and everything and all the precautions that you think you're taking. If you don't take into account the devices that have been rooted, really you're doing yourself and sometimes the user, even though one would indicate they did it to themselves, a disservice by not taking those into account. Okay, so the basic file system permissions. uh, what in general is it doing? It's giving you the ability to do any combination of the three. Either you're reading, you have the ability to read and write, excuse me, or you have the ability to read and write and execute, or like I said, any combination of the above. The app can override the default setting permissions unless otherwise explicitly instructed to not do so. Right. So, for instance, if you have an app that is in a read mode, um, unless expressly identified to be able to now I can read it and then I will write to another file. We essentially keep all stored data within its sandbox environment, and it will never write it back out. One would indicate that sure, that's a secure posture to be in until you have to begin to recall that data with limited flash memory available, because it's going to begin to override itself, um, uh, because it needs to be able to write it back out to some sort of either internal or external media to make room for more data as it processes. So what we're looking for is to set the correct flags, either mode world readable or mode world writable, to be able to fully execute, read and write permissions within the file system. Once again, this is extremely important when you start dealing with the different versions of Android, and what was possible with earlier versions. Now you have to expressly permit, and the later versions as the security of the operating system begins to evolve. So here we go. Once again, the SD cards, they're meant to be mobile, right? They are portable storage, just like a flash drive, right? You put it flash drive in one PC, you dump some data onto it, and you air gap it to another when there's not a network available, right? It's not meant to be used for or static or secure data storage. Right? It's just not what the design was. Um, so if you're going to allow your apps to offload and to write to external storage, you're going to have to enforce your own security mechanism, i.e., provide some sort of data level or file level encryption onto that SD card, so that the app can use the extended capacity to write data. However, the sensitive data that is being written to the XD card is not or does not remain in the clear. You're going to have to invoke an encryption mechanism onto that SD card for the user. It's not inherent or default within the operating system itself. So, and then obviously, once again, we talked about it. So Steve says you got your users are brilliant. They always back up their junk. So um, there's no need to really go over this, right? Users are the detriment to their own data more than any attack can hope to be, just simply because machines are going to fail, and if you don't take precautions to back your data up, you essentially will DOS yourself, because now the availability is going to greatly suffer as to whether or not it is going to be going to be available to you later when you need it. Right. And just earlier this afternoon, I was looking for a file from 2 years ago. Um, I had to go through three different hard drives to find it, but it was there right when I needed it, or relatively when I needed it, within the same 24-hour span. I guess that's close enough, right? Um, Okay, so how do we deal with extraction of data, and what do we have to be aware of, and how do we best protect ourselves against it, right? So, there's a number of ways that this happens, and several ways to be, I guess, aware as far as which vector of attack we're going to deal with, right? So a malicious person or a malicious app um, who has possession of the phone, right? Now we're talking physical possession, not logical possession. It's pretty easy to read and remove any data that's stored on the external SD card, for instance. Um, Physical possession, right? That's why they always say, right? Possession is 9/10 of the law. If I got it, I will own it. That's just kind of the nature of what we do. However, if the data is stored more securely, right, in the internal storage, thinking that we're going to bypass the inherent vulnerability of external storage, uh, once the device is rooted, once again, all bets are off, right? So now I have an app that I'm not going to allow to write externally because that is what I've considered to be the highest vulnerability. Once again, once they have the phone, they can access the internal memory. So if I haven't used good secure practices with internal protections, or the user has rooted their phone once again, or device, once again, you're dealing with a set of issues where the data uh, has now been exposed. Okay. Um, so now we deal with, okay, so uh, let's say they've wiped the internal memory. You're forcing a data purge um, at every power cycle, or you're ensuring that the data somehow, or whatever, is even the user erases the data. Um, since we're dealing with physical possession, there are many forensic tools that can be downloaded, and a lot of them for free, to restore what is thought of as erased data. Right. So, so now we've identified what three modes of attack. Right. Just external SD card being employed, internal storage. Um, of data, and now just simple forensic analysis with a set of freeware tools is all leaving the data open and accessible to any malicious person or malicious application. So all this to not necessarily say, well, it's a hopeless venture, but once again, this is why we employ defense in depth, right? We force encryption onto external media. We force the app to purge its data at power cycle. Um, when the app reopens, it opens in a secure state, meaning the user has to re-enter its identification credentials, right? Going back through the ID, authent, and author. That's why we build these layers upon layers into it, because we're not going to stop it wholesale. It is something that we have to just make it so resource intensive that essentially the attacker chooses to go for a softer target. Okay, once again, this really shouldn't. This isn't new stuff. This is kind of just kind of reiterating or hammering home. If you're creating like a study book for yourself, here's a good recap slide for you, right, with the highlights pointed out. App isolation is only at work while the operating system is running, right? So once the operating system is not running, basically it's just static data that once I mount the hard drive, uh, all the isolation protections are gone. Um, uh, all types of data storage are prone to attack. So the only way to ensure that we're thinking and building securely is by employing defense in depth, right? Giving them layers upon layers to have to work through. And of course, lastly, encryption done well is a strong countermeasure. Um, However, I guess that begs the question: what is encryption done poorly? Um, so I guess encryption done poorly would be storing both public and private key in the same device, where once I capture one, I capture both. All right, so I guess that would be an example of encryption done poorly, right? But that's the ecosystem failing, or that's actually I guess the design or the user failing more than it is the algorithm or the mechanism truly failing on itself. Okay, once again, so here here's a series of content, less context. Um, However, I would pull out for you to be familiar with mode private, mode world readable, and mode world writable, right, for internal storage. Um, the good part is it's not hard to really remember. Or, yeah, it's not hard to remember or force recall. Internal storage, private, world readable, world writable. Right. So the pretty simple three options to deal with. Um, External storage. Well, you see, right? Files all world readable, right? Unless otherwise invoked. But that kind of goes against the idea of why we have the SD card in the first place. Uh, Shared resources, right? Shared internal storage. You're still doing the same three. Private, world readable, world writable. The only odd man out here now is multi-process, but that is kind of as descript. Um, it's doing both, right? It's word readable, word writable, and then it's doing some combination of multiple execution levels. Okay. Um, so once again, more content than context, but those would definitely be the highlights that I would want to make sure that you understand for testing purposes. Okay. Um, and actually, I tell you what, just so I can kind of plan the next half of this. What are you guys kind of feeling at this point? Do you want to push through another module, um, or when we get to the end of module 6, since that's all really we were holding you accountable for, you want to stop there? So Bo's easy. Todd wants to press. Okay. Okay. Um, and I'll keep reading your responses as we go. And like I said, it's gonna let me um, kind of plan the rest of the rest of the evening. Okay, so at this point, this is kind of a nice natural pause break. So what we'll do is we'll take a short break here, let you refill your beverage of choice, and then we'll come back and hammer through the last section of this. I won't even call it the last half, but the last section, and make an overall decision where to go from there. Okay, all right. So let's take a short break here, and we'll be right back. All right, guys, welcome back. Um, and here's I guess where I'm at. I look forward through the next module, which is a little longer than these. So actually, I think it's going to force us back into kind of being on time, and rather than quitting halfway through a module, we're probably going to just end early. And it also give you some time to catch up on the labs that you haven't done, or get ahead. For instance, with the labs for tonight for modules 5 and 6. More importantly, Karen was, since she I think is the only female here, since it is the day after Mother's Day, she said stop. So we'll do what Mom wants to do, and we'll stop. Okay, so um, like I said, I always let the mob rule, and mothers always count for double, I think. Okay, so we'll press on through the remainder of this module. We'll take a look at looking forward where we're going to in the next meeting, and then we'll call it an evening, early present for you. Okay. Moving forward, what do we deal with when we deal with some of these storage types, whether they be internal or external in nature? Um, uh, there's always content providers to take into account, right? So uh, essentially, what is a content provider doing? It's providing controlled access uh, to some database through an app, right? It's doing it without requiring that the database itself be directly shared. For instance, the contacts would be considered a content provider. Right, a list of stored phone numbers, addresses, emails, birthdays. That would be considered a content provider in this discussion. Uh, uh, Obviously, there are many other applications within the Android archetype that we would put in this same class, but that is the most shining example of what we would be talking about when we deal with a content provider. You are free to use the content provider to provide structured storage exclusively for your application. So, if I'm, building an email app, then obviously I would want to access the contacts content provider to leverage ease of use for my email application, and they are there freely for you to use. You will have choices to make. You can export your content to permit access to other apps. So, for instance, you've developed an email app and you've developed a the next best phone book, rather than using the default or onboard contacts application. So you can pull in information from the content provider and then permit access to other applications to use that same data. So now you begin to see, uh, the waterfall, right? The cause and effect. I'm going to pull from one, use for my structured requirements, and then I'm going to allow another app that hopefully that you wrote because you're using signature required flags to then use that same data that you exported, and allow it to import into that application for use. Uh, Depending on the level of permission that you are assigning or are requiring. Um, for instance, private access, you need to address that within the app manifest itself, and then as we spoke about on Tuesday, you want to mark the content, right, as exported false, right? So, if you don't want to allow the app or the yeah, if you don't want to allow another app to use the data that you have pulled from contacts, you would assign exported false to prevent further data aggregation. Uh, However, if you do want to enable other apps to export data from your application, you change the flag from exported false to exported with the attribute of true. Okay, so prevent data export from your app, export false, uh, allow export true. Okay. Um, Granularity is the key here, right? You want to keep the permissions as specific as possible, and then again maintain the inherent use of the signature protection level. So that only the data is going to be shared among your own apps, the apps that you have written or you have signature uh, to aggregate these data or aggregate the data across multiple applications within the ecosystem itself. Okay. Um, uh, Here's another review of what we've just covered. Um, Basic guidelines, right, of uh, s- how to protect, what is the best countermeasure when dealing with storage, internal, external, or otherwise. Uh, First, foremost, avoid storing or caching data in the first place if you can. However, we understand, obviously, in the real world, that's just often not um, an option for us, right? We're going to have to store sensitive data or cache data in some mode or method. So the data that is stored, for instance, in the internal storage, rather than external. Right. So if you have an option, if you have to store the data, if you have to cache the data, uh, you would prefer first to store it internally, where you are enjoying the protections of the base operating system itself, rather than external storage, where you lose all file permissions that are provided by the base Android OS. Set the file permissions to provide the minimum access required. So, minimum access required. Here's a pop quiz for you. What is another way to state minimum access required? Right? What are we practicing when we say I'm only going to allow you the minimum access required to perform your function? There you go. All right, Paul. Least privilege. Exactly. So yeah, I told you there's not going to be a test at the end, but I might do a pop up every now and again. Uh, Layered protection, right? Layered protection from the outside in, from the external to the internal. If I can encrypt the database, then I'll encrypt the file. If I can't encrypt the file, I'll encrypt the data itself. I'm going to use high quality encryption versus okay, conversely, low quality encryption. So yeah, I will always opt towards AES encryption, vice DES encryption, if system resources are available. Okay. Sanitizing your inputs, right? So when you say sanitize your inputs, or making sure you have input validation, essentially what we're doing, since we are talking about all of these apps are working on a back end SQL or MySQL or SQLite database, is trying to prevent or at least hinder from SQL injection, right? From uh, causing the data that's stored in the database to be either exposed or otherwise the integrity of it brought into question. uh, Storing executables, code, and scripts in external storage, right? So I racked my brain as to one good reason why that would even be a consideration, and for the life of me, could not come up with one. I mean, I know why I would do it within an enclaved environment, right, where I'm talking about multiple computers and whatnot. Okay, plugins. Okay, so storing plugins and external storage. Um, hmm. Okay, so Paul, can you help me a little bit a little bit on that? So what type of plugin would I store? Um, on external storage, and why would I store it there versus internally to the app? I mean, and this, honestly, this is an opportunity, at this point, to, right, teach the teacher. I mean, there might be a real good reason to do it that I just couldn't think of. Let's see. So, if other developers need to provide the code, not sure it's possible for them to use the internal for the app if they don't own. Okay. All right. Okay. So, all right. Well, yeah. That and I guess that makes sense, right? A game like Minecraft, maybe, or something like that, right? Where you're having to do constant cross pollination, multiple users, multiple places, who knows what type of device. Um, um, okay, so all right, so yeah, that, I guess that makes sense, right? Um, so there's a good reason, and like I said, I sat and tried to think it through. However, I'm not I'm not a huge gamer, right? I get lost for hours in Candy Crush, so. Uh, but I'm familiar with a lot of the games because they cause mass confusion and headache when I try to secure enclaves. Um, you'd be surprised how many WoW servers I found on networks that the boss didn't know was there, right? So I had to learn about some of these games. But okay, so that's a good example, right, of why you would store external code or scripts. Um, or I'm sorry, store code or scripts on an external storage device, one I didn't think of. So thank you, Paul. Appreciate that. Keep that in mind at a later date. Uh, and then okay, so verify that third-party components used by your app does not store or cache sensitive data. So while, for instance, the external code for Minecraft, I would probably indicate it's not going to store sensitive data. Um, I've seen Minecraft played. I don't remember putting in my social security number or anything like that, but maybe you did when they had to start the game or whatnot. But um, I would be more concerned, for instance, with banking applications, uh, cross pollinating and cross scripting than I would probably with Minecraft or Duke Nukem. Is Duke Nukem still around? Does anyone play Duke Nukem anymore? Uh, you can tell I don't do a lot of games, so um, those that's about about the extent of my gaming knowledge. Right, I remember Duke Nukem and Doom, and I watched my little girl play Minecraft 20 years ago. All right, so I dated myself. Thanks, Steve. Appreciate it. Uh, okay, so I'm gonna deal with my crushed ego, and maybe I'm not as young um, as I thought I was anymore. That hurts, Steve. That's okay. Um, Okay, specifically, getting into the specifics. Once again, we touched on this earlier. Be able to pull out the differences, if you will, internal storage versus external storage. Remember, internal storage is the one with your three options, right? Private, world writable, world readable. That's kind of how you're going to pull that out. The external storage itself. So yes, I'm going to write to the external storage. I'm going to read from the external storage, and that's about the limit of where you're going with it. Okay. Um, important highlight here. Android 4.2, uh, read external storage is automatic. It's default. Okay, so anything on the external storage device, whatever it is, um, by default in 4.2, is at that point considered world readable by default. Okay, so that is a good piece of testable information there, discerning at what point did it change. All other versions prior, you had to invoke the read external storage permission, if you will. At 4.2, it became automatic. Um, so that really is the kind of takeaway here. We've touched on all the highlights of the rest of this in the prior slides. Um, so dealing with the external storage itself, how do we deal specifically um, with it? We would indicate that we want to ensure, right, that we're performing good input validation, uh, once again to protect against SQL injection. Like, whenever you see the words input validation, start immediately thinking of database, SQL, MySQL, SQLite. It really isn't going to make that big of a difference for you. What they're wanting to push you to is some sort of SQL injection, or overall SQL vulnerability is the intent here. Um, so what you want to do is first you're going to check for the media availability, get external storage state, right? That is going to tell your app the state that the external storage is currently operating in, whether it's operating available, mounted, um, or unavailable. Okay, was it removed correctly? That annoying pop-up that I get when it tells me that I made a boo-boo and pulled my card before dismounting it. Okay. Um, Ensuring proper uninstall of your app, right? So, in a lot of ways, depending once again on the sensitivity of data that you're dealing with, the uninstall process is almost, and I would almost indicate as important as the operation of the app, right? So, if I'm dealing with banking or email, or often, some uh, would include photos, especially these days, into that high sensitivity, or requiring a higher level of protection due to their sensitivity. The uninstall process of your app is almost um, as important, right? So you want to ensure, when you use get external files drive, um, that at that point you have the control, right? How are you going to ensure the wipe of memory, right? Standard um, uh, ones and zeros, you're going to require 3 passes or 7 passes before the uninstall is complete. That's kind of where you have that um, uh, final say, right? The final goodbye, to ensure that while I protected your data to my utmost ability, while you trusted me with my application and operation of my application. Now that you're moving to a different application, I'm going to ensure that I have cleaned up after myself, so that any exposed data will not be due to me. Okay. Um, and then the last bullet here that I've highlighted for you, once again, it's not new. It's just kind of continuing to hammer home uh, the importance of signed and encrypted data transfer, right? Especially when you're dealing with external media, SD cards, and the like, that only permitting signed operation, signed with digital certificate, running good encryption uh, should be the default, not the afterthought. Okay, it's a lot easier to build this in up front than it is to come back after there's been a breach that you now have to deal with. And that brings us to the close, right? So, not too far, not really too far ahead, but I guess about where I thought we would be, about 40 minutes ahead of time. So, all in all, not bad. But once again, when I looked at it, uh, I didn't know how much time we were going to have to spend on encryption. Some people get it, some people have never done it, some people it's just a review. So, you'll see there is a lab associated with this one, lesson 6, accessing local storage. Um, so by all means, take this time if you had nothing blocked out for these last 40 minutes to go hang out and finish up the labs that you needed to. Otherwise, go enjoy your families, whatnot. Um, we will be back, or let's see, lesson 7, and see if I can just maybe read ahead a little bit for you. Lesson 7, where what do we be dealing with? Networks and web services, the web view component themselves, and honestly, I think we're probably, and I'll look at it again, but uh, we might actually get through domain 9 as well, and protecting credentials, because none of those are real long. It just kind of all depend on question, and where if we get held up somewhere. Okay. All right. So, yeah, unless there are any questions or anything that anyone needs me to go back through, we can go ahead and close out here. You guys enjoy the rest of your night. I'm going to hang out for a little bit to see if maybe um, there is a question or two lingering. Otherwise, have a good evening.